All right, good. Now we can get going. Sorry for the delay. Number 2. We're going to use this formula. The total amount equals what we started out with, which was the little a, $8,000. Since this is always 1, and it's a plus because this is an investment that grows. So growth is plus. If it decays or decreases, it's minus. Okay? And 11%, which you put as 0.11, right? Move your decimal point to the left to the number of t years, which is 10 years. So you just put that in your calculator, and you get $22,715.37. Go to the nearest cent on the money. Kaylee. Yeah, it's just like this. Okay, number 3 is the bacteria culture one. So you got 3 answers for this. All right, it says write an equation that models the number y of bacteria after x minutes. So y equals, again, we're using that same formula that's up above there. Our initial amount was 2,000 bacteria at 8 a.m. and it increases or grows at 4% per minute. So it's 1 plus 0.04 after x minutes. So we just put x. So that was A. And then B is y equals 2,000, 1 plus 0.04. And it's set at, we started at 10 a.m. and it's 10:30 a.m. So what's my x value? 30, right? That's per minute that's happening. So that's a 30. So that came out to 6,486.8. So if you want to go 6,487, that's okay. What time were there 200,000? Okay, so in your calculator, all right, you're going to put y equals your answer to A, and y equals 200,000. Now, when you put that in your calculator and try to do the intersection, it gave you an error, right? Because I guess we got such big numbers. So we'll go to our table instead. All right. So we're going to go y equals 2,000. 1 plus 0.04 to the x. Make sure you put that in right. And then 200,000. Go to your table. Oh, I already got it at 60. But it's above 200,000, isn't it? So I got to go up a little bit. So there's 194 and 202. No, that's only 19,000. I'm off. I'm way off. Sorry. It's only 20,000, not 200. So I got to go further. And look, that's only 37. So you got to keep going. You can hold yours down. There's 100,000. 150. Getting there. Oops. Now it keeps going. What was it? 117? See, that's what happens. If I hit this too fast, it goes a little crazy for me. You guys can. So it's almost 197,000 there. and it's 200 and almost 205. So 197 is a little closer. So I went with 117 minutes. Okay, but it's asking what time, right? So what time is that from 10 o'clock? 11:57, right? Because 120 minutes would be 2 hours, right? That'd be noon. So it's about 3 minutes shy of noon. Okay. So you have to go to your table, it looks like, on that, because the numbers are getting big. So I would just suggest on Monday you just go to the table instead of do the second trace stuff. Because it's going to give you that error. Just waste time for you. All right, questions on that? Okay, number 4, population decreases. So instead of the 1 plus on this, we're going to do the 1 minus, that's all. Same formula though. Our initial amount was 85,000 people. And this time it's 1 minus, and that was about 2.8%, which is 0.028. And what should the population be in 10 years? So our X or T, our time, is 10 years. So I got 63,985.5. So if you want 63,985 or 986, I'd probably give it to you. Because you can't really count a half a person, right? Scott, put that phone away. Off your lap. Put it away. Thank you. Questions? So again, this is using the formulas, right? All right, number 5, we got our compound interest formula. Number 5, the money, the principal amount, the P was $3,000. 1 plus, it was a 2.5% interest, so 0.025. Compounded quarterly, that means 4 times a year. So N is 4, and then it's to the N times T, and it said, how much will it be in 2 years? So T is 2, or you can just put to the 8th power. All right. So when I put that in my calculator, all right, it's just 3,000, parenthesis, 1 plus, and you don't have to use any more parentheses, but that one we have right there. Well, I guess on this part, I guess. Some people are putting another set here before the 0.25 or 0.025. It'll do it in the right order. It'll do that division before it adds. Okay. And then caret. And then I know 4 times 2 is 8, so I'm just going to put an 8. So $3,153.32. Questions? Just using the formula. Barney, you got a question? Okay. Number 6, same type of problem, same formula. The Smiths have $10,000, so that's the principal amount. 1 plus, and they have 2.5% again, 0.025. This time it's compounded monthly, so that's 12 times a year. So N is 12. For how many years? 5 years. Find the balance. 12 times 5 is 60, so I'm just going to use a 60 when I punch it in my calculator. So that comes out to 11,330.01. Questions on using the compound interest formula. R is a percent, and how many times it's compounded in a year. T is the number of years. We should know what the numbers represent. We got all those right so far, didn't we, Trip? Yep. Good job. T is the number of years, the time. N is the number of times it's compounded in 1 year. So if it said daily, what do we use for N? 365. Yeah. Okay. So quarterly N is 4, monthly N is 12, daily N is 365. Yearly N would be 1. That would be like the ones from 2, 3, and 4. All right. Number 7. This is our continuously compounded problem. So that's this formula, which is in there. Again, P is how much money you start with, which was $10,000. E is second natural log. Okay, that's the button you push. R, again, is your interest rate. So it's 5.25%. So 0.0525. You move that decimal point to the left times the number of years, which in this case was 15. So mine, I'm going to have to put, well, it starts out, when I hit that, I think it gives me a parenthesis. All right. So I'll go to my calculator, 10,000. Oh, I don't need that. I'm going to E. Second natural log. Yeah, it gives me that parenthesis there. So 0.0525 times 15, then close it off. All right. So $21,978. And 95 cents. Questions? So second natural log to get that E. All right. So principal is the amount of money you start with. R is the interest rate. That's the percent. T is the number of years. E is just that natural log number. Okay. Number 8. Same type of problem. They give you the formula for your account, which was this. Okay. And the first question was, which person had the greater principal? If you look at the graph, what's the principal for your friend? How much money? Nobody can answer. Wow. Brendan?
4,200.
Yeah, 4,200. And how much is your principal, your beginning amount? 3,800, right? So who had the more money to start? Your friend, right? So first question, we'll just call it A. Friend started out with more. Friend's greater amount. Okay? Now we got to figure out the balance after 15 years. So I'm going to put a 15 where the T is there. That's me. And then the friend will look at the table, or not the table, the graph, and do it. When you put that in the calculator, that's $8,044.60. When I look after 15 years, which would be halfway between the 14 and the 16, and I go up, it looks to me like it's $7,000. You guys see that? So, do I have more money or does my friend? Me. Okay. So, very similar problem. Going to look at a graph and figure out what your friend had to start with and what your friend had after so many years. You figure out how much you had after so many years. And then the problem, remember, this number is how much you started out with, right? 3,800. So you should be able to answer those two questions. Okay, so the part with no calculator, 9 through 18. It's in exponential form. You're supposed to write it in log form. So log base 5 of 25 equals 2. Remember, 5 is a base, 25 is a number, 2 is our exponent. Remember, logs equal exponents. Number 10 is in log form. You got to write it in exponential form. So your answer would be base of 4 to the third power equals 64. Okay, just rewriting. Again, you guys are good at this. You should not miss any of these 4. Number 11 was natural log of x equals 4. So we're turning it into an exponential. What's the base for natural log? E to the 4th power equals x. Okay, so these two are the same. 10 and 11 are the same. All right, 12, it's in exponential form. You have to write it in log form. So it's log base 2. 2's are base of 32. Of 32 equals our exponent, which was 5. So we should not miss those 4. Simple stuff. You guys are good at that now. And then 13 through 18, we got to figure out. The answer. Well, this one's really easy. If the base is 4 and the number's 4, what's the answer? 1, right? Those just cancel, basically. So really, there's no work you got to do there. You should just know that. 14, log base 3 of 1/27. I told you to write it as equals x on these, and then rewrite it as exponential, just like you did up above. Now, 27 I need to write with a base of 3. So, in your head, you should be able to go 3 times 3 is 9, times 3 is 27. So it's 3 to the 3rd. Okay? So since it's in the denominator, to move that 3 up to the numerator, I have to make my exponent -3. So this answer is x equals -3. These are equal now, right? Once you get the bases the same. Number 15. We got log base 2 of 16. Remember, write equals x. And then write it as 2 to the x equals 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's 2 to the 4th. I got the same base, so my answer is x equals 4. $16. Log base 5 is 625. Remember, set it equal to x, so you can write it as 5 to the x power equals 625. Got to get 5 the base then. So 5 times 5 is 25. Times 5 is 125. Times 5 is 625. So that's 5 to the 4th. So my answer is 4. 17 and 18 are easier than any of them. If there's an exponent up here and these are both the same number, what happens to those two numbers, that log base 5 and 5? They just cancel. So the answer is just 2x. Simple. 18. 10 log of 8x, that's an exponent. If there's no number written for a base with my log, what is the base? 10. So what's the 10 and this log do to each other? They cancel too. So it's just 8x. Don't overthink it. Any questions? We're good, right? All right. Thanks for paying attention. That's all I got.